At this Computerland store in Foster City, California, there's a new piece of hardware competing for display space, a desktop scanner. There are still keyboards and mice, but increasingly people are using optical scanners to input information into a computer. Today we're going to take a look at the latest in image scanning technology on this edition of the Computer Chronicles.
Computer Chronicles is made possible in part by McGraw-Hill, publishers of Byte magazine, and Bix, the Byte Information Exchange. In print and online, Byte and Bix serve computer professionals worldwide with detailed information on new hardware, software, and technologies.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. Gary, you've probably seen this portable copier in several of the mail-order magazines. It's a mini Xerox machine using basic Xerox scanning technology. And watch this. I can just take this and sort of pass it over this page.
It's pretty good.
And I end up with, what's not too bad, an instant Xerox copy there. All of a sudden it seems everybody is into scanning, whether it's a little portable scanner like this or desktop scanners, optical character readers, digitizing. Why the sudden fascination with scanning technology?
Well, Stuart, of course, desktop publishing is a prime mover in that area. We're trying to include graphics now with text for assembling nice documents and things of that sort. A second area, facsimile transmission, for example. A lot of us experience that now in business and home, and so it's becoming very popular to represent information that way. A big movement is toward representation of information in electronic form, because that makes it a lot easier for you to assemble it, put it together, change it, alter it, publish it. In general, it's a more flexible way to just deal with your information.
Today we're going to take a look at the latest in imaging and digitizing technology, both from the hardware and software point of view. We'll see the latest in desktop scanners, imaging software, and a database for pictures. Now, as Gary mentioned, one of the reasons companies are getting into scanning technology is because it can be a very fast and efficient way to communicate complex information. We found one good example here in San Francisco at a company called Interocean Leasing.
Interocean Leasing is in the business of leasing marine containers for shipping cargo around the world. The firm has agents in 26 countries, and it needs to communicate with those people every day. The company used to rely on a telex, but it has recently changed to a PC-based facsimile.
There are, I think, two main advantages of the system. One is inherent in any facsimile system, that is, we can send images. If we need to send, as we frequently do, a contract or some other legal document, or photographs, drawings, specifications for new equipment, it's very easy to do that. The second main advantage of facsimile and of this system is its cost effectiveness. It's a very cost effective system, because you can take advantage of economy phone rates and send at whatever time is most advantageous to you.
The hardware required for a computer-based fax includes a plug-in fax card, a scanner, a laser printer, and software. A complete system can send and receive text or images at preset times, and it will store documents to disk to be retrieved later. While the electronically transmitted image lacks definition on screen, the laser output is more than respectable.
We find that these kind of functions make it much more versatile. Plus, we can also use the PC as a PC. The fax functions in background mode, so we can be using Lotus or WordPerfect or any of the other software programs we want to on that machine.
Joining us in the studio now is Mike Urquhart, Senior Software Engineer with Datacopy Corporation. Next to Mike, his boss, Rolando Estevarina, the President of Datacopy. Also with us, Jerry Burrell, Editor of Macworld Magazine. Gary?
Jerry, it seems like desktop publishing is a very important topic, both with IBM PC and the Mac. How do you see that split, and what's happening there?
Well,
because it relates to scanners, obviously.
The scanners have become important, and all of the vendors that we're talking about, Datacopy, perhaps the oldest amongst them, have migrated from the PC community onto the Macintosh because of the rapid development of desktop publishing. More recently, things such as 8-bit scanners that we're going to see today are really key for desktop publishing because of their importance in halftone printing.
Okay, Rolando, you have a product, a data copy product. Can you tell us about it?
Yes, in fact, we have a product line that encompasses scanners that start at low price and extend all the way up to high performance, high image quality. And as Jerry just pointed out, in fact, we see a definite shift, or at least growth in importance of the Macintosh in the desktop publishing area. This device that you see here is in fact a scanner. You can think of it as a copier that instead of making a copy into paper, makes a copy into the computer memory. You take an original such as this and you place it in the scanner as you would place it in a copier. This device in fact has a mechanism here that will create a digital image, a reproduction of that original in the computer memory. What we're going to show you in a minute are some examples of what you can do once the image is in the computer. The scanner creates the image. The software in the computer analyzes the content of the image. The analysis could refer to one of three things: picture analysis, as it may relate to desktop publishing, grayscale processing. The two important factors in that particular transaction relate to image quality. One has to do with detail. For instance, I have here an example of the finished product as it would come out of a laser printer. This is in fact the scanning of a watch put on the scanner. The detail or the resolution pertains to how small an element in the image I could see. The second element that relates to quality has to do with the grayscale. And as Jerry pointed out earlier, and the Macintosh makes possible by virtue of offering grayscale displays and abilities to process grayscale, we can now create images with computers for desktop publishing that very nominally reflect the images that you photographically would produce.
And you have an example here also of exactly this picture scanned.
Yes, what you see here is...
This is previously scanned and put into the
that is correct. It takes a few seconds to scan the image, and what we have done here is the image I put in the scanner is now shown in the screen. Now, Mike, if you can show us, we're going to do some changes or some processing in this image. What you see here is, in fact, the control screens of the software. To the left, you see those elements that will control the scanner itself, the resolution, the grayscale, and so forth. And to the right, you see the elements of the software that control the image processing, brightness, contrast, and other factors. Now, we have made some changes, and now we're going to bring a second image and show you the differences by, in this particular case, performing a function that is called gamma correction that has to do with changing the tones in the image.
So this is a result of changing that control panel then?
Changing the setups and then applying them to the grayscale image. And now we're going to illustrate that by showing you side by side the examples.
Before and after of having processed that.
How much memory does an image like that take? This is scanned at what, 300 DPIs?
This particular image is scanned at 300 DPI dots per inch or samples per inch.
Okay, and that would take how much storage?
About 1 megabyte for an 8.5 by 11 picture, 1 bit. Now, if you have grayscale,
if you're working with desktop publishing, obviously you want to be able to size things and scale them and so forth. Do you have the ability to do that as well?
Correct. Given the facilities I just outlined, we can literally change the shape, content, and size of the image.
Jerry, is desktop publishing the only application for using a scanner? How else are people using this?
Well, in fact, it wasn't. Both Kurzweil and Datacopy were two of the original companies that introduced scanning for optical character recognition, but we've never really seen that come to the fruition that we would have hoped. And so graphic scanning and the recent development of desktop publishing have become the biggest and most practical market for scanning.
Last question, about 30 seconds left. What should a consumer look for in buying a scanner? What are the relevant factors?
Probably several things. One is, what are the dot per inch? What are the number of bits that it's able to capture? Is it 8 so that it can capture a full 256 grayscales? Probably third, what are the file formats it saves in? Does it save in TIFF and EPSF so that you can use a product such as Image Studio to further manipulate the bitmap? And finally, how well does the manufacturer support you when you get it home?
Okay.
One last comment, if I could.
Yes, real quick.
We do offer, and others, character recognition software that will take an image from a scanner such as this and do the reading that Jerry was.
Gentlemen, thank you very much.
Thank you.
In just a minute, we'll take a look at some scanner software. Stay with us. With us in the studio now is Mitch Stein. Mitch is president of Spectrum Digital Systems, makers of Trueform. Next to Mitch is Mark Zimmer, a partner in Fractal Software and the designer of Image Studio from Letraset.
So, you know, it's one thing to scan an image into memory, but when you're using with desktop publishing, you really do things like scaling and cropping and making editing changes and things of that sort. Mark, what do you do with desktop publishing in combination with those editing kinds of features?
Well, the average person might use a picture in a desktop publishing program such as Ready, Set, Go or PageMaker, and the image itself, here's an example of an image, would be placed in the page, hopefully with the right brightness and contrast and retouched as well, so it would look as good as you could get, say, in a newsletter or whatever it's being used for.
Okay.
Give us an example of how you could sort of manipulate that image and make changes in it once you had it scanned in, Mark.
Well, this is an example of a woman's face. As you can see, the program allows you to zoom around an image so you can look at the actual details. Right now I've zoomed in on a wrinkle on her eye, and I'm going to try to get rid of it. I'll choose some similar texture from a nearby area in the picture. I'm going to use Option, Copy to Drag, and move the texture in. And now I've gotten rid of the wrinkle, as you can see.
So electronic plastic surgery.
Really, that's it.
Cosmetic surgery.
Right.
Okay.
Other examples might include changing the contrast and brightness of the picture. Let's get a fuller shot here. This program can edit contrast and brightness in real time. In this case, I'm tweaking brightness, and in this case, I'm tweaking contrast. I've gone to the highest contrast so we can now look at the levels of information within the picture. Back to normal. So you can adjust whatever brightness and contrast details, similar to the gamma correction capability shown in the data copy scheme.
How fine can you make those changes? I know she has a little wrinkle in the left corner of her eye there, which might be a little more difficult.
Over here?
Yeah.
Right. Okay, well, this wrinkle's a bit longer here. Wrinkles are just a typical thing. You might want to get rid of moles, teeth and the sort. Okay, there's the wrinkle here. Now what I want to do is I want to select some gray level area from the picture, move it on top of it, and that's doing a pretty good job. But over in here, you can see there's a slight difference.
You can see the surgery.
Right, so I'll undo and go over and choose an area that's more likely to be correct when I move it on top of it. And that produces a far better result. So we've gotten rid of most of the wrinkle there. You can also do other effects. Let me just show you this. For instance, you can blur things with the water drop. This is a tool here for smearing information. We'll choose a larger pen to show you its effect. See how the picture's being smeared. Ordinarily, you wouldn't want to do this on a picture just to touch it up, but it's very useful for typical photographic effects such as gauzing and things like that.
And you could do electronic airbrushing and so on.
Exactly. That's what it's.
Now, Mark, how does the resolution of a picture like this compare to, say, a photograph, 35mm photograph, just for comparison purposes?
Well, we allow any resolution picture. It really depends on the scanner's resolution. Again, at 300 dpi, we can input 8 bits per pixel, let's say. That would give you an 8 megabyte image on disk. One of the benefits of Image Studio is to compress. That would probably be a third or a fourth of its size on disk.
Could I ask you to get out of Image Studio, Mark, so I can get Mitch to load up Trueform, if you will, and if you can sort of take over the computer there, Mitch. What is the importance? We hear that for people who are not artists and don't know a lot of these terms, when we talk about the grayscales and the halftones, why is that important? What are we really dealing with there in desktop publishing?
Well, when you output a picture to a PostScript device, it will use halftoning to show the picture. Because the device is only black and white, it will have to use halftoning to show gray levels. We allow full halftone output capability, and we also allow several different screens for various kinds of visual effects.
Okay, Mitch, if you can, you've got it up there. Now, one of the problems is the tremendous amount of memory that an image takes up, and I think a form, in fact, is a particular problem there, isn't it?
Right. Typically, in a lot of desktop publishing applications, what people are really doing is only concentrating on a small area of a page. But in the case of a form, a letter size, or especially a legal size, you end up with a huge amount of data required. For example, if we take this form, this letter size page scanned at 300 dots per inch would take up 1 megabyte of memory.
Just for that one page.
Right, and then when you include on top of that the necessary software and operating system, you end up having to have perhaps 2 megabyte minimum Macintosh to be able to hold all of that
So
stuff.
how does TrueForm address that problem?
Well, what TrueForm does is on the fly while we're scanning, and by the way, TrueForm actually controls the scanning process itself, so as opposed to having to use somebody else's scanning software and then come into our product. On the fly, TrueForm takes the image and compresses it and writes it to disk. We're able to typically squeeze out 80 to 85% of the space.
That's got to do with the amount of white space, I guess, on a page.
Right,
So.
exactly. We capitalize on that. And again, one of the other problems with having that much data is that we need to be able to display it on the screen of the Macintosh, and the Macintosh is only capable of displaying 72 dots per inch. So one of the other things that occurs while we're scanning it is we're also reducing the resolution. So we actually have 2 images stored. One is a screen resolution image, and the other is the high resolution image that's used for printing.
So this is an example of how you would use a scanner, not in desktop publishing, but in a routine
Right.
business application where you want to electronically recreate a form and,
Sure.
of course, be able to fill it in, which is the
Right.
hard part in most cases.
The nice thing about it, when it comes back out, it looks like
Sure.
300
In fact, what you can see is that regardless of what the screen image shows, this is the original.
That you scanned in?
Right. And then this is what it looks like after we've set up all of the fields and filled the form out and laser printed it. So you can see that you have high quality photocopy sort of image.
Mitch, Mark, thank you very much. One of the serious applications of computer imaging is in the medical field, where doctors can use imaging for diagnosis and treatment. Wendy Woods has a report on that application.
For many doctors, this is a dream come true, a way to see inside the human body without surgery, its layers, its structures, its ailments. The technology called volume imaging was developed by Pixar. Data from CAT scans and other sources fed into the computer produces a variety of inside views of the human body. Johns Hopkins is among the few hospitals regularly using the Pixar in diagnosis. Doctors say the images alone have changed their decisions regarding operations or implants in nearly a quarter of their cases. But many wonder why, given the advances of today's computers, this technology took so long to produce.
Memory wasn't large enough, which is another way to say it wasn't cheap enough, so you could buy large amounts of it. And the processing power required to address all that memory wasn't cheap enough. But those things have changed. So Pixar is the first company to exploit cheaper processing power and cheaper memory to let us look at very large pieces of memory visually.
While the Pixar computer is not exactly inexpensive at $50,000, you must keep in mind that just 2 years ago, it was nearly triple that price. So enthusiastic has the medical community been to this new technology that people here predict that most radiologists will be using it within 5 years. By then, the technology is also expected to fit into a desktop machine and be radically less expensive. In San Rafael, California, for the Computer Chronicles, I'm Wendy Woods.
Joining us in the studio now is Jennifer Moeller, Marketing Director with Pictureware. Next to Jennifer is Mike Marcus, the President of Pictureware, and George Morrow, our resident commentator and expert.
Mike, so far we've seen 3 applications of flatbed scanners in desktop publishing, where we get black and white raster images, computer display, and so forth. Now, your product, Pictureware, how does that differ?
Pictureware enables you to get real-world pictures via video camera into a database. And treat that picture as though it's just another field in the database, so that now you can combine real-world pictures with text and data and retrieve those pictures based on whatever attributes are important to you.
Okay, what kind of computer hardware do you need to do that?
Jennifer?
Jennifer?
Well, as Mike pointed out, we have a video camera here which is hooked up to a board inside the computer, which will capture the analog image, convert it to digital for storage purposes in the computer, and then reconvert the image for analog for display purposes on a monitor. So we've got an IBM or compatible computer plus the video camera and monitor.
Okay, Mike, show us what kind of databases you have now using these digitized pictures.
As an example of the kinds of applications that we can think about marketing and sales applications. Real estate comes to mind immediately. Okay, jewelry comes to mind, where it's one of a kind. Then there are a class of applications that we call identification applications signature verification, for example, or a security access control system where you want a picture of a person and whatever text is appropriate.
And their inventory and parts, pictures and parts.
Yes. Yes, parts
So
inventory.
You're really addressing the problem of how do you manage all these images once you get them inside your computer or into some file.
And how to use them with databases.
Yeah.
Exactly. What we're trying to do is take advantage of the fact that computers, PCs, can now handle real-world images, and we can integrate these images into real-world applications.
And Picture Power then works with a standard database? Is that what we were saying?
Picture Power has its own internal DBMS, and it also has its own internal data communications module so you can communicate pictures. But Picture Power is also capable of operating with other database management systems.
Okay, and you're in Picture Power itself now, Jennifer, right?
Yes, now we're in Picture Power. We have a list of databases in the system currently. We can pick up one, for instance, a real estate database, and we can browse through the records sequentially, one at a time. In this case, we have a single picture with associated text fields at the bottom. We can pick up a second database, an art database, for instance. And in this particular case, we have 3 pictures, all of different sizes. The system gives you the ability to customize your database so that you can put any number of pictures in any size in your database.
And you can also edit these pictures, apparently, also.
Yes, you can annotate them, etc. We can pick up a person database now. And in this case, again, we have a single picture field, a number of text fields along the side. Scroll through the records. And Picture Power gives you the ability to query on selected criteria. In this case, we're indexed on first name, so we'll type in Mike's name, and up comes his image.
And there's his file, yeah.
Now, in addition, we can add a picture to the database. For instance, we'll add Stuart's picture, we'll add it to this picture field here, go to our picture directory where we've previously captured Stuart's picture. We'll pick it up.
His smiling face.
And this is just another piece of information, right?
That's
Which
right.
we're going to put into
Besides Stuart's picture.
into a database.
And Picture Power will automatically paint your image in a matter of seconds to the database.
George, what do you think about all this stuff, all this scanning and organizing of images?
Well, Stuart, most of the information in society is either on film or on 8.5 pieces of paper, 8 by 11. Here, this technology, both the hardware and software, allows you to bring that in and treat it as information the same as you would a name or an address. Now, once you do that, you're going to have benefits far beyond
Like what?
Well, look at these grocery chains that have taken barcode reading and turned it into marketing tools about how well bread sells with 7 feet of shelf space or 3 feet. When you get a lot of information you can manipulate, there's much more there than meets the eye on just the mass of it. Asking questions about it, analyzing it, and having to be able to do that with virtually everything around now means the access to understanding what's going on in fields.
And managing pictures and images in addition to words and text.
Well,
and visual
what
forms.
this does is allows us access to a tremendous amount of information that is not digitized or not in informational database form yet, and now all this stuff does that.
George?
Tremendous step forward.
Mike, Jennifer, thanks very much. That's it for
Thank
our
you.
look at PC imaging and digitizing. Hope we'll see you next week again here on the Computer Chronicles.
In the random access file this week, it looks like 1989 will be the year of the HyperCard clones. OWL International's already out with a guide, a hypertext program for the Macintosh and Guide 2. Hypertext program for 286 and 386 PCs. Silicon Beach Software is set to release SuperCard, which it describes as an authoring system that can create standalone applications outside the hypertext environment. Format Software is about to announce Plus, a color hypertext program for the Mac. Xanadu is promising Hypergrid, written by hypertext creator Ted Nelson. Bright Bill Roberts is set to release HyperPad, which runs under MS-DOS. IBM has already announced Linkway for PCs, and Apple itself is promising a new release of HyperCard sometime next year. There's a new online service set to debut in January, which will feature online multitasking. The service is called Summit, and its terminal program lets you create up to 4 windows and run different online services simultaneously in each window. There's a standard hourly rate regardless of how many applications are running and regardless of the speed of your modem. General Information is introducing a phone management system called Hotline. It comes with a database of 10,000 business addresses and phone numbers. You can add floppy disk libraries of industry-specific listings. Hotline also maintains an automatic phone log. Samna Corporation is now shipping its much-touted word processor called Amy. It brings full WYSIWYG word processing to the IBM PC world. It runs under Microsoft Windows and includes a runtime version of Windows. Command Corporation has introduced a new speech recognition system called the Bug. It can recognize more than 50 active words out of a vocabulary of 200. Each recognized word can be used for an individual command or for a pre-programmed macro sequence. The basic system sells for $799, which includes a plug-in board, software, and headset microphone. Time now for Software Review. Here's Paul Schindler.
Here's your coffee, Mr. Schindler.
Thank you very much. In the movies, they call that person a gopher. Whatever you need, they run and get it. Now, there's a computer analogy which goes, interestingly enough, by the name gopher. In this world of 40 megabyte disks, it becomes increasingly more difficult to find something you wrote months, weeks, or even days ago. There are lots of indexing programs on the market, but they tend to be awkward and space-consuming. Now there's Gopher. This memory-resident program can pop up and search for text. It does Boolean searches for two terms related by and, or, nearby, and not. It can ignore uppercase or lowercase or consider them. It can look for the word exactly as it appears or something like it. It can search a single directory or the entire disk. It can be taught to ignore files that aren't text files. If you aren't sure where to have Gopher look, he'll show you a map of your disk. It's probably a lot easier to use than whatever method you use now to keep track of your old text files. Gopher is $60 from Microlytics in East Rochester, New York. For the Computer Chronicles, I'm Paul Schindler.
The Pentagon says it has organized an antivirus SWAT team to combat computer viruses which threaten Defense Department computers. The group is called CERT, for Computer Emergency Response Team. It consists of 100 top computer experts and investigators. Headquarters for CERT will be at Carnegie Mellon University in Pittsburgh. Software game makers are saying they are running out of ways to make computer games more exciting due to the limitations of current technology. At the PC Outlook conference in San Francisco, several game publishers said they are hoping that the growth of CD-ROM technology will provide a new and more powerful platform for sophisticated game development. Finally, Game King Nintendo says it is working with AT&T to develop a two-way video game service linking a game software library with users and providing the ability for two players at different locations to play against each other via phone lines. Nintendo says it will offer adapters to its existing video game consoles that will be able to access the new service. That's it for this week's Chronicles. See you again next time.
The Computer Chronicles is made possible in part by McGraw-Hill, publishers of Byte Magazine, and BIX, the Byte Information Exchange. In print and online, Byte and BIX serve computer professionals worldwide with detailed information on new hardware, software, and technologies.
For a transcript of this week's Computer Chronicles, send $4 to PTV Publications, Post Office Box 701, Kent, Ohio 44240. Please indicate program date.